In this lesson, we're going to solve equations that have rational expressions in them, specifically those that have rational expressions with the variable in the denominator. In these, we are going to have to check our solutions to make sure that whatever we get does not cause a denominator to equal 0. Remember that the domain of a rational expression or a rational function is restricted when any number makes a denominator equal to 0. That'll make a little more sense when we actually take a look at it within a problem. I am hopeful that you remember from a pre-algebra class or an elementary algebra class solving equations with fractions that we find the least common denominator and we multiply every term by the LCD. We will then have no fractions. We can solve that equation, but we have to check our solution and make sure that it does not cause one of the denominators to become 0. In our first problem, we have w over 7 plus 7 is equal to 8. The denominator, the only denominator is 7, so the least common denominator is 7. I'm going to multiply every term by 7. So I have 7 times w over 7 plus 7 times 7 equals 7 times 8. It doesn't matter whether the term is a fraction or not. If you multiply one of them by 7, you multiply all of them by 7. So now I need to simplify each of these products. The first one, if I put the red 7 over 1, we can see that those divide out, leaving me with w plus 49 is equal to 56. We now have a nice linear equation to solve. I'll subtract 49 from both sides. That gives me w is equal to, 7. There is no variable in the denominator, so in this problem there is no chance that my denominator could go to 0. So I would choose this and I would fill in with 7. It's just a coincidence that that denominator was 7 and I got w is 7. All right, let's look at another one. I have x over 3 plus 5x over 12 is equal to x over 9. All right, my common denominator, I need something that I really just need to focus on the 12 and the 9 because anything they will go into, 3 will go into also. So I believe that our common denominator is going to be, what, 36? I think that's going to be right. So if I multiply 36 times x over 3 plus 36 times 5x over 12 equals 36 times x over 9. Put the 36 over 1. 3 goes into itself once. 3 goes into 36 12 times. 12 times x is 12x. Plus, put the 36 over 1. 12 goes into itself once. 12 goes in there 3 times. 3 times 5x is 15x. Equal sign. Put that over 1. 9 goes into itself once. 9 goes into 36 4 times. And I have 4x. Now this is a little unusual because all of my terms have x's. If I combine these, I have 27x is equal to 4x. The rule is when I have variables on both sides, I have to use addition or subtraction, depending on the signs, to eliminate one of them. I eliminate that for 0, and this is going to give me 23x is equal to 0. Divide by 23, x is 0. Now, if x is 0, does that make this denominator 0? No. This one, no. This one, no. So this is a completely valid answer. X is 0. My eraser doesn't want to work. Well, there we go. All right, the next one. I have 5y over y minus 8 plus 1 is equal to 8y over y minus 8. Now you might notice that I've spread this out a little because I'm going to use a little technique, a little bit on the lazy side, but it's going to save me some writing. I need to multiply this fraction, this number, and this fraction, each by the common denominator, which is y minus 8. So I'm just going to sneak it in. For the first one, the y minus 8's divide out, and I get 5y. For the next one, I have 1 times y minus 8, which is y minus 8. For the last one, the y minus 8's divide out, and I get 8y. All right, on the left, combining like terms, that gives me 6y minus 8 is equal to 8y. Going to subtract 6y from both sides. Negative 8 is equal to 2y. Divide both sides by 2, and negative 4 is y. We look back up at the original problem. If y is negative 4, does that denominator become 0? No. Does that? Well, that's the same denominator. So if y is negative 4, I'm not doing a full check. I am just checking to see if it violates the domain. The only number that would violate the domain in this would be 8. If y were 8, I'd have a problem, but it's not. So my answer is negative 4. The next one, I have a over a minus 9 is equal to negative 7 over a minus 5. Now, this is something that's going to lead us into another section. This kind of equation is called a proportion. A proportion is when you have a single fraction equals a single fraction. When you have a proportion, the cross products are equal. So AD is equal to BC. Now we're not solving. This was just an example to remind you of how to solve a proportion. It's only a proportion when you have one fraction equals one fraction. So we have not been looking at proportions because we had 2 terms equals that. And up here we had 2 terms. And up here we had 2 terms. So none of those were proportions. But when we have gotten to number, there it is, number 4, it is a proportion. So this product equals this product. Doesn't matter which side you write them. A times a minus 5, that's the green product, equals a minus 9 times negative 7. On the left, I have a times a is a squared. A times negative 5 is negative 5a. On this side, because the way I wrote it, I'm going to have to distribute from the right. Negative 7 times a is negative 7a. Negative 7 times negative 9 is positive 63. Now, in this equation, now you can see that it is quadratic. So from a previous lesson, you should remember that when it's a quadratic, we have to get it set equal to 0. That means I'm going to add 7a to both sides. I'm also going to subtract 63 from both sides, and I'm just doing both of those at once. That gives me a squared plus 2a minus 63 is equal to, those have both canceled out, and I have 0. I have a quadratic equation. It's equal to 0. So I will try my factoring. Equal to 0. 1 plus, 1 minus, factors of 63 that have a difference of 2. So how about 9 and 7? Outer product is negative 7a, inner product is 9a. That gives me 2a. Now the zero factor property says either a plus 9 is equal to 0 or a minus 7 is equal to 0. A is equal to negative 9 or a is equal to positive 7. Those may possibly both be answers, but I need to check. If a is negative 9, that denominator would be negative 18. That's okay. If it's negative 9 here, that would be negative 14. That's okay. If a is 7, that would be negative 2. If a is 7, that would be positive 2. The numbers that would be troublesome would be if a equals 9, that would be a bad answer, or if a equals 5, but it wasn't either one of those. When you answer this in my math lab, you would separate them with commas, so you would have negative 9, comma 7, and it doesn't matter which one you write first. All right, looks like we have one more to practice on. All right, when I write this down, I'm going to go ahead and write those denominators in factored form, and that's going to help me figure out the LCD. I'm also going to space it out. So I have 4y over, there's a common factor of 3, so it's 3 parentheses y plus 3, plus, spacing it out, we have 9y minus 11 over, factoring this, I see a common factor of 2. 2 times y plus 3. Equal sign. 5y minus 8. And y plus 3, I can't factor, I'll just leave it like that. What is the LCD? Well, I need one of every different kind of factor. So I need a 3, I need a y plus 3, and I need a 2. So the LCD is, let me write it down, it is 3 times 2 times y plus 3. 6 times y plus 3. So 6 times y plus 3. 6 times y plus 3. 6 times y plus 3. And you can see it was just a little bit of laziness on my part that I didn't want to rewrite that. That's why I left space on the left side of each one of the terms. In the first one, the y plus 3's divide out. 3 goes into itself once, 3 goes into 6 2 times. I have 2 times 4y, which is 8y, plus the y plus 3's divide, y plus 3's divide out. 2 goes into itself once, 2 goes into 6 3 times. I have 3 times 9y minus 11. Equal sign. The y plus 3's divide out, and I have 6 times 5y minus 8. All right, let's use the distributive property where we need to. I have 8y plus 3 times 9y is 27y. 3 times negative 11 is negative 33. Equal sign. 6 times 5y is 30y. 6 times negative 8 is negative 48. Combine these two like terms. 8 and 27 is 35y minus 33 is equal to 30y minus 48. I choose to get the y's on the left, so I'm going to subtract 30y. That gives me 5y minus 33 is equal to, those are gone, negative 48. Add 33 to both sides. I have 5y is equal to negative 15. Divide by 5. Y is equal to negative 3. That's a nice answer. Let's check it. It's easiest to check in the factored forms. If y is negative 3, what happens to this denominator? That becomes 0. That's a violation. That becomes 0. It's an additional violation. That becomes 0 because negative 3 plus 3 is 0. It only has to happen once, but in our problem it happened 3 times. The y equals negative 3 is a solution to this equation, but unfortunately it is a violation of the domain and cannot solve the original problem. So I have to get rid of it and respond that there is no solution. With rational equations, you must check your answer to see if it violates the domain of the original problem. Okay, now you work on yours.